We're told in this question that a sequence is generated by this recurrence relation. Now remember the way we write terms of a sequence. That is the first term, that's the second term, that's the third term, and so it goes on. That would be the nth term, that's the one after the nth term, whatever that term is. We add 1 to the subscript here. So there's the nth term and there's the n plus 1th term. So this recurrence relation tells us how to get from one term, say the nth one, to the next one, the nth plus 1th term. And there's the formula that does the trick. We're told to multiply the previous term by m and then add 6. So to get from there to there, we're going to do two things. We're going to multiply by m, that's the first one, and then we're going to add 6. That's the second action. So to get from one term to the next, multiply by m and add 6. Now that's going to be true all the way along the sequence. We're going to have to multiply by m and then add 6. Multiply by m and then add 6. So we now have clearer in our mind the process to go from one term to the next. Now we're told that the first term is 28 and that the second term is 13. And from these two pieces of information we're asked to find the value of m. So let's just follow this process through. To get from 28 to 13, remember we said that's a multiplying by m and then an adding 6. So let's just write down what that means. If we start with 28 and we multiply it by m, we'll get 28 times m and then add 6. And that ends us up at 13, the next term. So this must be equal to 13. Let's take 6 from both sides. And let's divide both sides by 28. Now there's a factor of 7 in 28. 4 sevens are 28, so we can divide top and bottom by 7. 7 into 7 is 1, 7 into 28 is 4. So we get the fact that m is a quarter. So let's now have a look at part B. So what we found in part A was that m equals a quarter. So we now know that this recurrence relation, to get from one term to the next, we multiply the previous term by a quarter and add 6. So this part B asks us to explain why this sequence approaches a limit eventually. Remember, we're starting with the first term being 28, the second term being 13, the third term, fourth term, etc. And so it goes on. And we now know we multiply by quarter, add 6, multiply by quarter, add 6 to get the sequence of numbers. And eventually we're asked to explain why this must approach a limit. And the reason lies in this multiplier. So long as that multiplier lies between -1 and 1, there will be a limit. And you have to state that very clearly. So the multiplier, a quarter, lies between -1 and 1, so there exists a limit. And let's call it L, because we don't know what it is yet, as we go along the line of values. Eventually they'll level out and reach some number L that we don't know as yet. And we're asked to calculate that limit. Now suppose that eventually we do reach this limit. The whole purpose of calling it a limit is the fact that if we perform the process to go from one term to the next, and if we've reached the limit, then nothing will happen, we'll stay there. So that's a way of hunting down what this number is. So if we carry out the times a quarter and add 6 to L, we'll just end up with L. So a quarter of L, whatever it is, plus 6 must give you L. And therefore we can do normal algebra to solve that equation. Let's get rid of fractions, multiply both sides by 4. 4 times a quarter L will be 1L. 4 times 6 is 24. Take L from both sides. 3L equals 24. Divide both sides by 3. And we get 8. Now you can check that if you start with 8 and you perform the times by a quarter and then add 6, just check what you get. What's a quarter of 8? It's 2. What do you get when you add 6 to 2? You get 8. So that indeed is the limit. The limit is 8. Now there are other methods of working out that. There's formulas involving A's and B's and all the rest of it. Often people tend to muddle them up and forget them. So I like this method. Figure out what happens if you have reached the limit. Apply the recurrence relation to L and you'll end up with the same thing. Solve that equation.